Hi guys, so we'll be solving an O-level past paper question from the year 2014. The session is May-June. This is question number 9. This question is based on mensuration. So let's start. The question says the diagram shows a solid cone of height 15 centimeter and base radius 6 centimeter. Part A says show that the slant height of the cone is 16.2 centimeters correct to one decimal place. Okay. In order to find the slant height, let's say that the slant height is L. The formula that we use is Pythagoras theorem, that is L square equal to the base, which is 6 squared, plus the height, which is 15 squared. Let's put this into the calculator. 6 squared gives us 36 plus 15 squared gives us 225. Add the two. When we add the two and find the square root, L square becomes 261. So L would be equal to the root of 261, which is equal to 16.2 centimeters. The next part says calculate the total surface area of the cone. In order to find the total surface area of the cone, you need to add two different surfaces. So the total surface area of the cone is equal to the curved surface area plus the base area. Now the base area of this cone is very simple to find. This is only a circle, so you do pi r squared. So let's do that first. So base area is equal to pi r squared. Pi is 3.142 and r is 6. So you square this, find the base area, and that comes out to be 113.112 centimeters squared. I'm using the full value right now. The other one, that is the curved surface area. The curved surface area can be found by using the formula pi r L. When we use pi r L, you do 3.142 times the radius, which is 6, times the slant height, which is 16.2. When you multiply this, your curved surface area comes out to be 305.4. Now let's add the two. You add 113.112 plus 305.4. This equals 419 centimeters square. That is the total surface area of this cone. So this is 419 centimeters squared. The next part says calculate the volume of the cone. The volume uses a simple formula, that is 1 over 3 pi r square h. So you do 1 over 3 times 3.142 times the radius, which is 6 squared, times the height, which is 15. When you multiply all these values, your volume comes out to be 566 centimeter cubed. So you put the value over here, 566. The next part of the question says the cone is made from wood. The mass of 1 meter cube of the wood is 560 kilograms. Calculate the mass of the cone in grams. First of all, if you look at the previous part, the volume that we found was 566 centimeter cubed. But over here, the question is saying 1 meter cube is equal to 560 kilograms. So you convert 566 centimeter cube to meter cube, which becomes 0.000566 meter cubed. You divide 566 by 1 million. Now, if 1 meter cube is equal to 560 kilograms, how much would be 0.000566 meter cube be equal to in kilograms? When we cross multiply this using the calculator, let's see what we get. X is equal to 0.000566 times 560. This gives us 0.31696 kilograms. But the question is asking you for the mass of the cone in grams. So you multiply 0.31696 by 1000. This comes out to be 316.96. You convert this into three significant figures. So your mass of the cone becomes 317. You write the value over here, 317 grams. The next part of the question says another cone is made of the same material and is geometrically similar to the first. The mass of the cone is double the mass of the first. The mass of the second cone is double the mass of the first. The first part says calculate the height of the second cone. Okay. First of all, since you're talking about mass, the similarity formula that we use over here for the masses is height 1 over height 2 whole cubed is equal to mass 1 over mass 2. The question also says that the mass of the second cone is double the mass of the first cone. Let's see what the mass of the first cone is. The mass of the first cone that we found was 317 grams. Okay. So if the mass of the first cone is 317 grams, you multiply that by 2, you get 634. That's the mass of the second cone. The height of the first cone is 15 and the height of the second cone is unknown. So you cube this. Let's see what we get. The values that we get are 15 over h2 and find the cube root of 317 over 634. Okay, when you solve this further, this becomes h2 is equal to 15 over, I'll write down the simplified value. If I plug this into the calculator, I get 0.7937. So the height of the second cone comes out to be 18.9. This is the height of the second cone. Okay, the next part of the question says, calculate the total surface area of the second cone. Now we are finding the surface area in this case, so we still use the heights, which is h1 over h2, but over here, instead of cubing it, we square this because we are comparing the two areas. So this becomes surface area 1 over surface area 2. Okay, so the height of the first cone is 15, the height of the second cone is 18.9. There is a square on top of both of them. And the surface area of the first cone we found was 419. We need the surface area of the second cone. Okay, when we square this 15 and 18.9, you get 225 over 357.21 is equal to 419 over surface area of the second cone. When we cross multiply this and find the value of the surface area of the second cone, this becomes 419 times 357.21 divided by 225, and the surface area comes out to be 665 centimeters squared. You write the value over here, 665, and we're done with the question. I hope this question made sense. The complete working of the entire question is present in the description below for you to download. If you like this video, hit the subscribe button, and thank you so much for watching.